Hey everybody, today we're going to be talking about how you can use angle relationships. Specifically, we're going to be talking about how to understand and use complementary, supplementary, vertical, and adjacent angles to answer questions. So before we do this, we need to make sure we understand some basics. The first thing we need to understand is what makes up an angle. Every angle has a vertex and two rays. And when we look at this angle or this example of an angle in particular, you're going to notice that ray 1 and ray 2 form this angle here. And when we understand angle relationships, we can understand what the measure of an angle is. Let's take a look at another one. If you see, we have what's called angle A, B, C. So whenever we name an angle, we start with a ray, we go to the vertex, and we go to the other ray. So you're going to notice that most or all angles have the vertex labeled in the middle. So we have ray BA and ray BC, and they both meet at the vertex, which is labeled B. So this is important to understand that an angle has a vertex and rays, so that when we go to look at something like adjacent angles, we understand what that means. So that leads me to, what are vertical and adjacent angles? Well, vertical angles are formed when you have two intersecting lines. So if you take a look here, we have this line, which is being intersected with this line. And what happens is we end up forming these opposite angles. Let's see if I can get out of this real quick. So now if you look here, when we have these intersecting lines, they form opposite angles. And what's really cool about these opposite angles is they are congruent. Congruent means if we know that this blue angle is vertical with this green angle, then we know if this angle is 133 degrees, then X also has to be 133 degrees. You can see this example up here. So you can see that we have two intersecting lines. We have line CB and we have line AD. You can see the D got kind of cut off. And what happens is they form vertical angles. So we have this angle that's 110 degrees is vertical to this angle, which is also 110 degrees. You're going to notice too that the other vertical angles that are formed are 70. So vertical angles are awesome because if you know one, then you know another angle, which can be very helpful when you're looking at diagrams, etc. Now, adjacent angles are just two angles that share a ray. So in this diagram, there are two different angles. I have angle A, B, C, which is this 22 degree angle. And then I have angle C, B, D as my other angle. Now these angles are considered adjacent angles because they share ray BC. They both have it. You're going to see BC here, you're going to see BC here. So, adjacent angles, I like to think of them as neighbors that share a fence. They're just two angles that are right next to each other. They can be helpful as well. I think vertical angles personally are a little cooler. Now, there's two other angles that we need to know. One is a complementary angle, which is hopefully somewhat familiar by now. And if not, hopefully it will be. And complementary angles are just two angles that add up to 90 degrees. So if we take angle A, and we take angle B, and we add them together, they equal 90. Now you're going to notice in this picture that angle A is adjacent to angle B because they share this ray right here. Now to be complementary, you do not have to be adjacent, you just have to be, or they just have to add up to 90, but you're going to see that most of the time when we look at complementary angles, they look like this where they are adjacent. Now the other type is a supplementary angle, and a supplementary angle is cool because it's really just a straight line broken into two angles. If you notice, we have this line right here, and any straight line is 180 degrees. So you can see that it's been broken up into angle A and angle B. Well, if a straight line is 180 degrees, then A plus B also has to equal 180 degrees. So we can use vertical, adjacent, complementary, and supplementary to help us kind of answer questions with interesting diagrams. Before we do that, though, I want to make sure we can do some basics. So let's start here, which is, can we name an adjacent angle? So remember, an adjacent angle are two angles that share a ray. Now in this picture, there are tons of adjacent angles. So let's take a look at some examples. So one pair, and I'm just going to kind of label them over here, of adjacent angles can be seen here. So take a look. We have angle A, F, B. I'm going to go label that over here. Angle A, F, B, and angle, going back to where I left off at B. If I go back down, B, F, C are adjacent angles. Now, I want you to kind of think about this. If you notice, adjacent angles usually share two letters. We have FB and BF because of the direction I read them. So, angle AFB and BFC are adjacent angles because they share this ray FB. Now there are other adjacent angles here. So let's just look at two more examples before we kind of go on. Example 2, I could say that angle AFE is adjacent to angle EFD. So now I have this green arc AFE and angle EFD are adjacent angles. So I want you to kind of pause and I want you to think to yourself, what's another pair of adjacent angles? Now there's lots of possibilities, so I just kind of want you to look and think about it. And let me give you another example. So, example number 3. I'm going to reuse one of my angles. I'm going to say angle EFD, which I used in my last one and I'm going to use again, and that's okay, is adjacent with this guy right here, DFC. So as you can see, I just ended on DFC, get it? Anyways, nerd alert. There's lots of adjacent angles and I can reuse them to name other ones. What's really important is that you realize that these angles always share a ray. Now you're going to also notice that angle DFC is a special angle. You should know this, hopefully by now from other activities that you've done, that this is a right angle. So let's go check out if we can name another pair of another type of angle, which is the vertical angle. So when you look at vertical angles, the first thing you want to do is ask yourself is, do you see two straight lines intersecting? And two straight lines that intersect means they cross over each other to form an X. So you're going to see if I look at this guy, FC, he doesn't form an X because he doesn't keep going. But you should see that line AD, this beauty right here, and line BE, whoa, do form that kind of X. So this is going to be helpful because if I can see this X, BE, and AD, I can find my vertical angles. So of course I used a blue pen, but I'm going to kind of darken this. So these guys right here form an X. And wherever that X is I'm going to be able to find a pair of vertical angles. So let's take a look. If I look here at angle AFB, I have to figure out what angle is opposite this. Well, if this is my angle and I go opposite or across my X, I hit this area right here. And this angle is named EFD. So one pair of vertical angles I have is angle AFB and EFD. And notice I had to cross this intersection or that X to get to it. You should notice that this little red arc and this little red arc look to be about the same size, which should happen with vertical angles. Now there's another pair of vertical angles here. Hopefully magenta works. Let's see if this one works out. Magenta's all right. So then if I look, the other guy is, you should see that there's this arc right here that's formed by that blue X, or my intersecting lines. Well, this angle is called angle AFE, and it is vertical. If we look, angle AFE, it's vertical to this guy right here. Now, this angle is really hard to see because it's being broken up by this ray. If I look at this arc right here, this arc is formed by BFD. I want you to really look carefully. Maybe trace with your finger on the screen, angle BFD, because BFD is being broken up by this guy right here, and that's okay when we're looking at angles. There's tons of ways to name angles, and what's important is how you name it. So BFD is this large obtuse angle, and it is vertical to AFE. So if you need to rewatch that, I would highly recommend it because vertical angles are going to be important. Make sure you're taking notes as you're going and you're really making sure you understand what I'm saying. If you need to, you could always pause the video and go Google other examples of vertical angles or adjacent angles to help you make sure you really understand those two things. So we talked about vertical angles, we've talked about adjacent angles, we've talked about complementary and supplementary, and now it's what the heck does it matter? So if you take a look, it says we're going to use angle relationships and we're going to be solving for X. So there's a couple different ways that we could approach this problem. So here's what I see. I see that this angle CFD is a right angle, and right angles are 90 degrees. Now, the other thing I see is that I'm trying to figure out what X is. Well, the cool thing about right angles is they always have a neighbor that's usually a right angle as well. What I mean by that is if angle CFD is 90 degrees, then angle CFA, this guy right here, is also 90 degrees. And the reason I know that is because, let me see if I can highlight this in a different color. If we look at this right here, A to the F to the D, this is a straight line. And straight lines always add up to 180 degrees. And 90, this guy, plus 90, this guy, will make 180. Now this is going to be helpful because I can use that to find X. Let me pick a different color. My bad. Sorry, guys. So if I take a look, if I know that angle X and this angle, which is 50 degrees, have to make 90, then what I can do is I can say, all right, I could write an equation, and I'm going to do both ways. And I could say, all right, X, this angle right here, plus this angle BFC, which is 50, have to equal 90 degrees. So when I do this, we know how to solve equations. We want X by itself. I draw my fence. If you look, I have plus 50. To undo 50 or adding 50, I would need to subtract 50 from both sides. This makes my zero pair, and I get X equals 40 because 90 minus 50 is 40, which means X equals 40 degrees. Some of you are like, Mrs. Bailey, if I know it's 90, can I just do 90 minus 50 and get my answer of 40 degrees? And my response to that is absolutely. However, it's good to be able to see how you could use an equation because sometimes it's going to be a little bit more complicated. So I want you to see it both ways, but if in your head you were seeing 90 minus 50 equals 40, you're off to a good start. So let's look at another one. This is slightly more basic, and I say that because there's not a whole lot going on. What you should notice is that we have two adjacent angles side by side, and together they form a right angle. And a right angle equals 90 degrees. So, two ways to do it. You can think about it like an equation, which is what I'm going to do, or you could think about it as straight subtraction. I know that angle X plus the angle that's 62 degrees has to equal 90 degrees. So what I'm going to do from here is I'm going to solve my equation by drawing my fence. To undo addition, we use subtraction. Whatever I do to one side, I do to the other. This makes a zero pair, and I have X equals. Now, love you guys, but do not do 0 minus 2. You need to borrow. The 9 becomes an 8, the 0 becomes a 10, 10 minus 2 is 8, and 8 minus 6 is 2. So we get that X equals 28 degrees. And notice I am using the degrees symbol. Could you have just done 90 minus 62 to get 28? Absolutely. But again, I want you to get used to seeing the equation. So I notice there was nothing on the screen that was like, Mrs. Bailey, this is a complementary angle. What I noticed is that I had two angles side by side that made a right angle. And I know that two angles that make 90 degrees are called complementary angles. So sometimes it'll tell you have complementary angles. Sometimes you'll just see because they'll give you that little clue with that little box telling you have a 90 degree measurement. So let's keep going. This time, if you take a look, we have a straight angle. I see it right here. C to O to A is a straight angle. And if I have two angles that make a straight angle, they're called supplementary angles. And supplementary angles add up to 180 degrees. Now, unfortunately, we need to know what X is. So I can use what I know. I have X degrees plus my acute angle, which is 38 degrees. And I can see that together they make angle COA, which is a straight angle, which adds up to 180 degrees. So I can go ahead and draw my fence. To undo addition, we're going to use subtraction. Whatever I do to one side, I do to the other. This makes a zero pair. They cancel out. I bring down what I'm left with, which is my X. I bring down my equal sign. Again, please don't tell me 0 minus 8 is 8. We got to go borrow next door. 10 minus 8 is 2. 7 minus 3 is 4. 1 minus nothing is 1. So I get X equals 142 degrees. I would like you to notice that I can kind of check to see if my answer makes sense. The angle I'm looking for is COB, and if you look at this angle arc, it is an obtuse angle, and 142 degrees is an obtuse measurement. Again, some of you might be thinking, Mrs. Bailey, can I just do 180 minus 38? Yes, but please get used to seeing the equation. On to the next one. So, this one's a little messed up because the directions aren't great. So here's what's going to happen is I'm going to tell you that these two angles are complementary angles. Right now in your brain you should be thinking, what do we know about complementary angles? You should be thinking that complementary angles add up to 90 degrees. Well, it says we need to solve for X. And if you look here, we got angle 2 times X degrees, and then we got this other angle that is X degrees. So how are we going to do this? This is why I said get used to the equation. So let's check it out. I can take this angle, which is 2x degrees, or 2 times x degrees, plus this angle, which is x degrees, And I know that these two bad boys together have to equal 90 degrees. Well, some of you might be looking at this going, how does this help me? Well, check this out. I'm going to draw my fence, and then we're going to do something we have never done in an equation, but you have done before. You should notice that 2x plus x, those are like terms. They both have an x, which means I can add them together. 2x plus 1x makes 3x. And then I can bring down my equals in 90 degrees. Now I'm going to read this bad boy for meaning. This says 3 times x equals 90 degrees. Well, how do we undo multiplication? We use division. I'm going to divide this side by 3. I'm going to divide this side by 3. 3 divided by 3 is 1. 1 times x is just x. 90 degrees divided by 3 is 30 degrees. So in this case, when it says solving for x, I get that x equals 30 degrees. So this angle right here is a 30-degree angle. The one thing I want you to notice, though, is that the other angle is not 30 degrees. This angle that I'm going to highlight in green is 2 times x, or 2 times 30, which means that this angle that's in green measures 60 degrees. And sure enough, 60 plus 30 equals what? 90 degrees. All right, if my memory serves me right, we have 2 more examples. So let's check this out. This one says solve for angle 1 and 2. So we have to figure out what is angle 1, that guy, and what is angle 2. Oh, cradola. So when you look at this, there's tons of different ways to do this, which is why I love angles, because how I might solve it might be a completely different way than what you see. So let me point something out that I notice right away. I notice that this angle, or this line, see it? This guy is intersecting with this line. So if you look, I got this line and I got this line, and together they make an X. And some of you might be going, I don't care that it makes an S, Mrs. Bailey. And I'm going to say, why, yes, you do. And the reason why you care is because when you have intersecting lines, you have vertical angles. And if you can find vertical angles, then you don't have to do much work. Check this out. I kind of highlighted my intersecting lines in red. And if you notice right here, I have this angle that measures 54 degrees. And if I go opposite that angle, I get its vertical angle. And vertical angles are congruent, which means if this angle is 54 degrees, then this angle is also 54 degrees. Boom, kids. Here's what just happened. I just found out that angle 2 is equal to 54 degrees. And I didn't have to do any equations, any adding, any subtracting. I just had to see that X be formed. Now, that was pretty cool. If you don't think it's cool, rewind it and watch it again, because it was pretty cool. Now, here's the other thing that I see. I see this beauty right here. You see this guy in green? This beauty is a straight line. Straight lines add up to 180 degrees, or measure 180 degrees, I should say, which means angle 1 and angle 2 right here are supplementary angles. They add up to 180 degrees, which means I'm going to label this guy X instead of 1 because I don't want it to be a number, okay? This means angle X plus angle 2, which we now know is 54 degrees, has to add up to 180 degrees. So ladies and gentlemen, we get to solve this equation. Here we go. I draw my fence. I undo addition with subtraction. Subtract 54, subtract 54. This makes a zero pair. I get X equals, again, don't you be go telling me that 0 minus 4 is 4. You can't take away 4 from nothing, so we got to fix that. 10 minus 4 is 6. 7 minus 5 is 2. 1 minus nothing is 1, which means, ladies and gentlemen, angle 1 is 126 degrees. That was pretty cool. I love angles. If you're not loving this, well, we'll talk later. All right, if I'm correct, this is the last problem of the day. I know you're secretly crying. So let's check it out. It says, using angle relationships, if angle AOE is 60 degrees, what is the measure of angle EOD? Well, first, you got to figure out who the heck is angle AOE. So if I follow it, A to the O to the E, here is angle AOE. And it tells me that this beauty right here is 60 degrees. So the second thing you should be asking yourself is, who the heck is angle EOD? Well, angle EOD is this guy right here, and I'm going to label him X because I don't know what he is. So again, I want you to notice a couple things. There's a ton of different ways you could do this, all right? That's the most important thing you need to know. The thing is, we should all get the same answer. So if you notice, line AOD tells me that this guy, angle AOE, and EOD together make supplementary angles. They add up to 180 degrees. If you don't think an equation's coming, you're crazy. So what this means is I can take angle X plus angle AOE, which is 60 degrees, and together they must make a supplementary angle, which comes out to be 180 degrees. So I draw that fence. To undo addition, I must use subtraction. Whatever I do to one side, I'm going to do to the other. I have a zero pair. Boom, I'm left with X. I'm happy. He's isolated. Equals 0 minus 0 is 0. 8 minus 6 is 2. 1 minus nothing is 1. So I get that this angle EOD, is 120 angles. Or degrees. Oops, sorry, 120 degrees. So notice, obtuse angle, obtuse measurement. This is looking pretty good. So, like I said, I'm pretty sure, yep, that's it. Phew. So if you need to rewind that to make sure your notes are taken, please feel free to. I hope this video helped you understand the beauty of angles. If it didn't, you need to do some more Googling because maybe I did not do it justice. But angles can be pretty cool if you can start to visualize the different relationships that you have. Anywho, hope you enjoyed it. And yeah, I look forward to talking to you guys later. See ya.